Got done a little early tonight. Got everything put away in the shop. Figured I had a little extra time, so I'm gonna go over a little handout. I've been doing some hands-on motor grader training for my local South Dakota LTAP, and I just figured I'd go over that handout, and figured some guys might find that useful. So we have your ideal shape of the road. We kind of recommend 20-foot road top, no more than 26. That's getting plenty wide. You want it to be like a roof peak. So you come down here, ideal, you have a 4% crown. You figure 1/2 inch per foot. So you can kind of read down there. You go, modified A is what we're looking for. Parabolic is you have that worn out cutting edge, you get kind of like haystack. Excessive crown, you get way too peak. You have your flat, no crown, and inverted. Definitely don't want them. We want to strive for the figure up top and for your modified A as a 4% cross slope. So, turn the page, and you have your illustration of how you would articulate. So if you want to take and get a more of a aggressive angle on your moldboard going to the left, you put your tandems towards the ditch line. So this is always kind of interesting to some guys. We all run 16-foot moldboards here in South Dakota. That's pretty well standard. But with a 14-foot moldboard at a 30-degree angle, you're only covering 12.1 foot. And at a 45, you're covering 9.9. So very, little room there for error. You go 16, you can get 30-degree angle, you're covering about 13, roughly 14 foot. And then 45, you're covering 11.3. That's why that 24 to 22 foot top is about ideal, because you want to keep that 45-degree angle to minimize the material you're losing out the end of the moldboard. So we go over here and we have the moldboard pitch. So the first one would be for aggressive cutting. Mainly would use that when you're trying to move a big windrow or cut, hard dirt or anything in that nature. Number 2 is a good cutting one also, not quite as aggressive. And then number 3 is your kind of general maintenance angle. I'd say anywhere between 2 and 3. 2 is a good one for pulling in, and 3 would probably be a good one for blade and the windrow off. Generally I roll my blade all the way ahead and then back a little bit. So we have a proper illustration of going into a curve. So you never want to have a curve with a crown in it, because that's extremely dangerous. So you want to have your transition so they can bank going around the curve. That's a common mispractice by a lot of operators. They try to carry the crown through the curve, which you don't want. So that kind of illustrates how you would want to have your bank. And then this here illustrates going up to a paved road. So you want to start by eliminating your crown as you get to the pavement, and then hopefully they got a lug out or an apron coming off the paved road onto your gravel, so you can pull material up to it and then back drag off of it, or keep it level there. So you want to eliminate your crown and have that flat. That's the one place you're going to want to have no crown coming up to an asphalt road. So this is a proper shape of an uncontrolled intersection. You don't want to take and have any crown coming from all four corners. It's pretty much a duck pond. I know it sounds horrible, but technically if there's no sight obstructions, they're allowed to do the posted speed limit through each corner. So on a controlled intersection, you would carry, so the controlled intersection would be stopped going east and west, and then north and south you would carry your crown through that intersection, and then ideally the township or whoever it is that maintains the east and west will match your crown and then, you know, pull off of that. So you would taper your crown and match into their road on the through road. This is a big one with me. Aggravates the heck out of me. You get a farmer putting in a field approach or a acreage, new house going up. They take and build their driveway and they match the crown of the road. That's not how it's supposed to be done. So ideally you would have that picture down here below. They should match the edge of your road. I know some guys are gonna say, well, you know, we don't want to undercut that. Well, you have to. You know, ideally if you have the time, you take and cut it back, you know, push it back up into their driveway and make that a smooth transition, like this illustration on the bottom here. So this illustration is like a parabolic crown. So this can be caused by running regular true hardened steel edges where the edges will crown out in the middle. So you're either cutting on the center line or you're cutting on the shoulder. It makes it really hard to keep a, you know, roof peak in your road. And on top of that, it causes a secondary shoulder. So you can see underneath that 2x4 there's a lot of daylight there. Well, you don't want that on the road because it holds water and people can get in it, you know, cause them to roll, go off the road. Ideally, you want a nice, smooth hinge point off of there from the shoulder of the road into the ditch, so there's no gap there. I'm sure you guys have seen on my channel, I have a retriever disc. Mine's on the front of the motor grader. I got one on the moldboard, one on the back of a tractor. If you have a high shoulder, that disc is a very effective tool. Huge time saver, gets that cut off and all mulched up, and everything can break down easily. Highly recommend them. So, I recommend on laying new gravel, always take and equalize your windrows. When they're dumping, take and heel it all up, get it equalized into a uniform windrow, and then proceed the laydown process. And then lastly, on the back of this chart, and I'm sure a lot of you guys will find this helpful, but this is the main reason why we preach about staying into that no more than 26 to 24 foot wide. Sometimes you have to get wider than that, but this will really open some eyes to some county commissioners and supervisors. So you take a 24 foot road width and say you want to take and put down 3 inches of gravel, so you're almost at 2,053 tons per mile. So that adds up pretty quickly. So you come down here, and then it's got for a belly dump. So you figure 2,500 tons or 2,053 tons a mile. So you figure at 2,000. So you figure 2,000 tons. So a belly dump is going 66 feet. and then that gives you your specs on a end dump. So the wider you go, the more tons per mile it takes, obviously, and nobody's got just a magic budget for material. So as you can see, it gets very expensive in a hurry. So that's like a lot of my roads are that 24 to 22 foot range, and we try to shoot for 3.5 inches. So even at 3.5 inches, you're getting at that 20, dang near 2,400 ton per mile. So it gets expensive. Well, that concludes my little handout that we use for our hands-on motor grader training. If anybody's got any questions or wants me to go over something again, just take and let me know, and appreciate everybody watching this, and take and like this video and subscribe to the channel for more. Thanks for watching.